Geometry, Chapter 2-7, the last section of Chapter 2. We're working on flowchart and paragraph proofs. Pause the video and come back and check your work. So if the two angles are equal, then they are congruent. If two angles form a linear pair, they are supplementary. And finally, if two angles are complementary to the same angle, those two angles must be congruent, right? Okay, so today flowchart proofs. We use boxes with arrows in a flowchart proof. The boxes contain statements and we put their justification for those statements underneath each box. Today we might be using this theorem, the common segments theorem. Given collinear points, A, B, C, and D, arranged as you see here, we're told if AB is congruent to CD, then AC is congruent to BD. Common segments theorem. So AC is simply AB plus BC, right? And BD is CD plus BC. So we're taking AB and CD and adding BC to each side. The addition property of equality. Very good. Okay. In order to understand how to make a flowchart proof, we're going to look at one already done, and we're going to organize this flowchart proof into a two-column proof, which you are already used to using. Okay. Notice the statements given, angle 2 and angle 3 are complementary. Angle 1 and angle 3 are congruent. We're proving that angle 2 and angle 1 are complementary. So we start a flowchart proof with what is given, right? The first thing given, angle 2 and angle 3 are complementary. So what can we say based on this statement? If angles are complementary, we can say, look at this, the angle sum is 90. That's the definition of complementary angles. Okay, so they went ahead and put both of the givens in the first statement. I jumped from here to here. And you could do that. You could do what they've done, or you could place this given statement on its own line, as you know. Okay. Let's go back and look at this statement. Angle 1 is congruent to angle 3. If they're congruent, what can we say about those two angles? We can say that they're equal in measure, right? So that's where you see that here. This statement that the angles are equal in measure flows from the fact that they were congruent, right? That's just our definition of congruent angles. So we just made these two definition statements, and so how do we get to this statement? So if angle 2 and angle 3 are complementary, and angle 1 and angle 3 are congruent, rather than saying 3 here, we can substitute angle 1 where 3 was in that statement, right? So we're using substitution to make this next statement, that angle 2 plus angle 1 is 90 degrees by substitution. If these two angles sum is 90, can we say they're complementary? Yes, we can, by the definition of complementary angles, which is our final box. So the first boxes are given, the final box will be what you have set out to prove, right? Okay, you go ahead and see if you can write a two-column proof for the given flowchart proof. Come back and we'll check. Okay, so we start with given, don't we? So we were told that RS equals UV and ST equals TU. So what can we say from that? Well, what did they say here? They said RS plus ST equals TU plus UV. RS plus ST equals TU plus UV. And this is just the addition property of equality. We're adding the same value to both sides. Now the value that we're adding to this statement is ST, and on the right side, UV. But we were told those two segments had the same value. So we're adding the same value to both sides of this original statement. Additive property of equality. We then see this box up here. RS plus ST equals RT. Well, that's just a segment addition postulate that we just talked about a couple slides ago, right? TU plus UV is this entire segment TV. So we can make that statement based on the segment addition postulate. That didn't flow from the given, so it has its own starting point. Okay. Since we've made this statement that RS plus ST is this, look at RS plus ST, that is over here as well, right? And then this expression, TU plus UV, is on the right side of this expression, so we can use substitution to say that RT equals TV. We were setting out to prove that the segments are congruent. We've shown that they are equal in measure, and so now we can say that the two segments are congruent because if segments are equal in measure, by definition, they are congruent segments. Let's see if you can make a flowchart proof with a two-column proof that has been given. Okay, we have been given that B is the midpoint of AC. Okay, so let's see. That's the given statement, right? B is the midpoint of AC, and the reasoning is it was given. That goes under the box. Okay, the next thing, AB, segment AB is congruent to segment BC. Well, that's our definition of a midpoint. That flows straight from the given statement. So we'll say AB is congruent to BC by definition of midpoint. We next see AB equals BC. Well, that's just our definition of congruent segments. Okay? And then we see this, AB plus BC equals the entire AC. Well, that's coming not from our previous statement, so we're going to begin a new box over here. That's just the segment addition postulate, right? And so now what can we say from these two boxes? If AB equals BC and AB plus BC equals AC, how can we combine these two? And you see we are saying that AB plus AB, rather than using BC, we're going to say it equals AB, so AB plus AB equals AC. That takes us to our final statement, which is what we set out to prove. Two ABs equal AC. And we see that here, don't we? And we see that just by simplifying that statement. Now your turn to give it a try. See if you can create a flowchart proof for this two-column proof. Prove that the measure of angle 1 is congruent to the measure of angle 3. Come back when you're ready to check it. Okay, we start with, you might have started over here with what was given. We also can state by the linear pair theorem that angle 1 and 2 are supplementary, angle 3 and 4 are supplementary. Okay, so if your boxes are in different places, that's okay, but those are the starting boxes, right? Angle 1 is congruent to angle 3. Angle 1 is congruent to angle 3 by congruent supplements theorem, right? If angle 2 and angle 4 are congruent, then we can say angle 1 and angle 3 are congruent. Finally, we say measure of angle 1 equals the measure of angle 3 by the definition of congruent angles. The second type of proof today is called a paragraph proof, and this presents the steps and reasons of a proof in a paragraph. So it's basically taking a two-column proof or a flowchart proof and writing it out in words. Don't forget to include every step. Here's a couple of theorems that we might add to our collection of theorems. The first one is vertical angles theorem. You know vertical angles. When we make a X with two segments that we have opposite angles are congruent, right? And if two congruent angles are supplementary, we can say if two congruent angles are supplementary, then each angle is a right angle. If they're congruent, two angles that add up to 180, they must both be 90 degrees. Okay, so let's use this paragraph proof, so you see one before you have to make one, right, to write a two-column proof. and then we'll write one later. Okay, so here we have given the measure of angle 1 plus the measure of angle 2 equals the measure of angle 4. That's our first statement in the paragraph as well. Okay, it was given. We're setting out to prove that the measure of angle 3 plus the measure of angle 1 plus the measure of angle 2 equals 180. That's what we're setting out to prove. What can we say from this first statement? We can say that angle 3 and angle 4, no, not from this statement. No, this is just simply from the linear pair theorem. Looking at this, angle 3 and angle 4 form a linear pair, right? And what's the next sentence? So measure of angle 3 plus measure of angle 4 equals 180 by definition, right? And so we're going to put that in there next. Do the linear pair. We have our definition of supplementary angles. By substitution, measure of angle 3 plus measure of angle 1 plus 2 equals 180. So rather than measure of angle 4, we're going to plug in this expression, right? That's substitution. We're substituting 1 and 2 for the angle, measure angle of 4, and that equals 180, which is what we set out to prove. Okay, so here's the paragraph. Here's the two-column proof. See if you can write the two-column proof for the given paragraph proof. Come back when you're ready, and you can check your work. Okay, so it's all been given to you. I hope that you were very careful, taking your time to really contemplate this, and you should have something like this. Now, if you put both given statements on one line, I can understand that. They did that a couple of proofs ago, didn't they? I kind of like how it was separated here, but there are different acceptable answers to this question. Okay. The nice thing about today is that we're given a proof and we're just transforming it to a different type of proof. So the work of creating the proof is already done for us, right? So let's walk through how we can turn this two-column into a paragraph. Here's our first statement. So we make that statement. We say angle 1 and angle 2 are complementary. That was given. So look at how they blend this into one sentence. So the measure of angle 1 plus measure of angle 2 equals 90 degrees by the definition of complementary angles. Angle 1 and angle 3 and angle 2 and angle 1 is complementary to angle 3, angle 2 to angle 4 by the vertical angles theorem. So we're just walking down left to right. Measure of angle 1 is congruent to the measure of angle 3, measure of angle 2 is congruent to the measure of angle 4 by definition of congruent angles. Next statement, by substitution, look at how they inverted this to be creative. They put the reason, they led with the reason. By substitution, the measure of angle 3 plus the measure of angle 4 is 90 degrees. So angle 3 and angle 4 are complementary by the definition of complementary angles. Your turn to give it a try. Write a paragraph proof for this little basic two-column proof. And then come back and compare yours with the paragraph that they've created. Your words might not be exactly theirs, but it should be something like this. Pause the video and make a comparison. Here's your assignment today. There aren't a ton of things here, but each of them is a proof. So be real careful, be diligent, do your best work. And then the next class will be a review session. So 2 classes from now, you'll have your Chapter 2 test. Have a good day.